Okay, so we're going to look at percentage and absolute uncertainty, and the main reason we use percentage uncertainty is because it allows us to calculate using uncertainty. So it allows us to transfer between units. We can convert it to a percentage, and then we can deal with different units. Okay, it's really, really powerful. But to do that, we need to go through a few steps. So I've broken this problem down into a few different sections to give you some scaffolding, and then you'll get a chance to practice on your own in a second. So the first thing I asked you to do is to measure the length of your page with an uncertainty. So depending on the ruler you're using, I'm assuming that most of us have got a ruler that has millimetre increments. So most people in the room, for their length of page, would have got 29.7 or something around that, plus or minus 0.05 centimetres. Most people probably found that was not too difficult, correct? Make sure the number of significant figures in your value and your uncertainty are the same, as far as it should go to the same decimal place. Now find the measurement for your width. Now, I didn't exactly check that, I didn't measure my width, but has someone got a width they used? Aiden? 21.00 plus or minus 0.05 centimetres, assuming we're using the same ruler. Are we clear? Most of us got that. Most of us got to question 3 here and started to struggle, however. So what I might do, I'll fix this up. It's too far now, of course. Most of us got to question 3 and started to struggle because new concept. We dealt with that last lesson. We now needed to deal with percentage uncertainty and how we find percentage uncertainty. And the way we go about doing that, so I'm just going to write percentage for length. That equals my uncertainty, my absolute uncertainty. So my absolute uncertainty is the absolute value, or the value I had for my uncertainty, which is 0.05, divided by my total value, which is 29.7. 0 if you want to be precise. And that gave me a value of, obviously times that by 100, sorry, I forgot to put the times 100. What do we get for that? 0.18%, which is teeny tiny, which is good. What about my percentage of width? What do you think goes on the top here? 0.05 divided by 21.00 times 100, and we get 0.24%. Happy with that? How do we calculate area? Area equals length times width, which equals, in this scenario, 29.7 times 21.00, and we get
623.7.
How many significant figures should I have?
4.
How many have I got? That's good. Centimetres squared. Happy with that? Now I want to add my uncertainties together and convert that back. Now this is the challenge. I'm assuming that most of us found this was near on impossible. Okay, so let's start by doing the first part of the problem, adding my percentage uncertainties together. So total percent equals percent length plus percent width. Why do you think I add my percentages together? What's the reasoning behind it? Correct. I'm assuming that worst case scenario, I've got to assume that I'm 0.5 too far, 0.05 either way, correct? So I have to add my uncertainties because I'm trying to go worst case scenario. Clear? If you're a little bit long and a little bit short on your width, what's actually going to happen? Is your answer going to be worse or better than being too long in both areas? If you're a little bit long in one, a little bit short in the other, is that going to be a more accurate calculation than being long in both?
Yes.
I think it will be more accurate.
Because that little bit that's
Cancels out a bit of error, okay? But we have to assume that our errors are compounding and getting worse, okay? So we get 0.18 plus 0.24, which gives us 0.42%. I'm pretty sure. How do we convert our percentage back into?
Do we just use the same equation?
Use the same equation. So percentage equals absolute divided by value. So we times both sides by the total value. So I would get, what's my value for my equation? What am I shoving into my value?
0.42.
That's my percentage, so I'm going to put absolute equals here. Just going to swap sides so I've got my room. Absolute equals 0.42, or do I write something else? Because what have I forgotten? That's true. That's right. It's not your job to be the critique. So I need to divide my percentage by 100 and multiply that by what value? What's that percentage represent? The total uncertainty for what? The length, the area? Area. So I need to multiply that by my area, which is 623.7, and I get, someone with a calculator, who is the calculator? 0.0042 times 623.7. 2.61954 centimeters squared. So my value, my final value, should have area equals 623.7 plus or minus 2.6 centimeters squared. You're right. Thank you. Absolute. Okay. So what we're going to do now is I'm going to get you to do exactly the same thing, because I know it was quite complicated and I know it's quite a bit to get your head around. I'm going to get you to measure the area of your iPads or your diaries, okay, with uncertainty. So you need to find the length, the width with an uncertainty, convert that to a percentage uncertainty, and then turn that back into an absolute uncertainty. Are we clear? Any questions?